Right. So how word order conventions emerge in the manual modality? There is an uneven distribution of word orders in the world's languages. By word order, what we mean is the order of subject, object, and the verb. And cognitive and communicative factors might be affecting word order preferences in world languages. And certain semantic roles might be preceding and following others based on these factors. So far, the most common word orders reported in world languages are all subject initial, SOV and SVO are the most prevalent word orders, and in these orders, S precedes O. And only a total of 3% of world languages are object initial. This is true for spoken languages, but also for sign languages. In a cross-linguistic study of word orders in 42 sign languages, SOV and SVO are still reported to be the most prevalent word orders. And there is also evidence coming from silent gesture paradigm for S preceding all word orders. And this means, irrespective of modality, there is an overwhelming preference for S preceding all word order patterns in world languages. So what is the reason for this prevalent preference? Event structure hierarchies, for example, animacy and agency, might be shaping word order preferences. The agency status of the grammatical subject of the sentence, well, subjects are very often the agents. Those are the entities causing or initiating the events. So seems like agency might be a factor in shaping word order preferences. And there is this principle called agent first principle turned by Jackendorf. And according to this principle, the prevalence of S preceding all word orders is the general cognitive preference for expressing agents before patients, and that is caused by our conceptualization of entities and events. Another factor, animacy, animate arguments seems to be preceding inanimate ones, and there is this theory called animacy hierarchy. There is a general preference to express animate beings like humans and animals before inanimate objects, according to animacy hierarchy. However, recent evidence coming from emerging sign languages portray a different scenario. They provide evidence for all preceding S word orders, and there's a systematic variation between S preceding O and O preceding S word order patterns in certain animacy cases. For example, so this is a study conducted on Said Bedouin Sign Language. In scenarios involving a human agent acting on an inanimate patient, the preference is for S preceding O, like this one, man taps watermelon. However, in scenarios involving a human agent acting on a human patient, like this one, man taps girl's shoulder, this time evidence from emerging sign languages, as I said, from Said Bedouin Sign Language and also from Central Taurus Sign Language, shows that there's a tendency for word order patterns involving all preceding S. Mayer thinks that there might be a human first principle operating here. However, this is a set limited with certain animacy scenarios in which there is always a human agent acting on a human or inanimate patient. And Mayer and colleagues acknowledge the fact that other scenarios involving, for example, inanimate agents acting on human patients should be tested. So all preceding S word orders is not only all preceding S word orders show up not only in emerging sign languages data, but also recent evidence from silent gesture with English speakers show some evidence for all preceding S word orders. In a recent study by Kokap and colleagues, they show that animate agents acting on an inanimate patient, that's a prototypical scenario. And again, they found evidence for S preceding all word orders. In scenarios involving an animate agent acting on an animate patient, this time there is also a tendency for all preceding S word orders. And in those scenarios involving inanimate agents acting on inanimate patients, they again find some tendency for all preceding S word orders. Another factor here might be the age of a language. Maybe in the initial stages of a language, all preceding S word orders may show up. And there might be a systematic variation in word order preferences in emerging sign languages, depending on the agent and patient animacy in the initial stages of language formation. So, in brief, there is an overwhelming tendency for S preceding all word orders in world languages. Possible factors for this tendency might be agency, like the agent first principle, or animacy, like the human first principle or animacy hierarchy proposed before in the literature. And recent evidence from emerging sign languages for all preceding S word orders in certain semantic animacy conditions poses some new questions in this line of research. And the age of a language might be a factor here. In the current study, we are interested in these questions: how do animacy and agency shape word order patterns in the manual modality? And how do these patterns evolve and conventionalize over time? So here, we compare three types of manual systems in different stages of conventionalization. So the first one is silent gesture. It's a paradigm used it's a paradigm in which the participants describe events using hands only and facial expressions, but using no speech. And the second type of manual system we have is an emerging sign language, Central Torus Sign Language. CTSL is a village sign language that is less than 50 years old, and it emerged spontaneously in a small closed community in South Central Turkey as a result of high instance of recessive deafness in the community. And the next manual system we have is Turkish Sign Language. It's the national language of the deaf community in Turkey. It's used in schools. And silent gesture, it's an improvised form of communication with no established conventions. CTSL is a system, it's an emerging sign language with emerging conventions. And TID is an older sign language with more established conventions. So here, this setup gives us a developmental trajectory of linguistic structures. In silent gesture, we had 28 hearing participants, all native Turkish speakers. In the second one, CTSL group, we had 13 deaf signers. All of them use CTSL as their native language and the only means of communication. And in the last group, we had 18 deaf signers, all native signers of TID, and they're all schooled. In the silent gesture group, they're also schooled. In the CTSL group, none of the participants are schooled. We had 45 short video clips of transit events where an agent performed an action on a patient. And we had 9 animacy conditions here. Building upon the previous studies, we had a complete set of animacy conditions, a human agent acting on a human patient, on an inanimate patient, and on an animal patient, and animal agent acting on a human patient, inanimate patient, and an animal patient, and an inanimate agent acting on a human patient, on an inanimate patient, and animal patient. So here are some responses from all 3 groups. Here we have a prototypical scenario: a human agent acts on an inanimate patient, and here we have a response, silent gesture response, I, woman, Tupperware, drop. It's an agent initial response, subject initial response, and here it's again a subject initial response, woman, Tupperware, drop in CTSL, and here in TID, woman, Tupperware, drop. Again, it's a subject initial response. Here we have in silent gesture, man running and goat follow. This time it's an object initial response. And here we have a CTSR response, man running and goat following behind. This one is also again an object initial response. In TID, this time a goat, man, run, follow. So this time it's a subject initial response. Here in silent gesture, there is one standing and ball hit. It's an object initial response. In CTSL, man with glasses stand and ball hit. It's again an object initial response. In TID, oh sorry. Man stand, ball hit, again an object initial response. Okay, so how did we code data? Here is an example. So here goat is chasing man. The ground rule in our coding scheme was irrespective of the position of the verb in a string, if the subject precedes the object argument, then that response gets coded as 1, or else it gets coded as 0. So here, man, run, goat, chase. Man is the patient here, so it's a O preceding S response, and it gets coded as 0. Man, run, goat, chase. Different phonology, but it's the same order of arguments. Again, it gets coded as 0 here. This time, goat, man, run, chase, and here the syntactic subject precedes the object, so it gets coded as 1. All right, results, Limor.
Okay, thank you, Rabia. So the first thing to remember is when we analyze the results, we use mixed effect linear regression models, logistic regression models, to predict, in this case, the proportion of S before O, or agent before patient, orders as a factor of the animacy of the patient, the animacy of the agent, and language age, and the interaction between all these factors. Okay, so the first result we found was that animacy affected word order across languages. I'm going to give you this kind of signal if you can change the, yeah. So in all our conditions, our participant tended to front the animate entities. That means putting the animates first. Animate agents elicited more SB4O orders than inanimate agents. So what you can see here on the x-axis is the animacy of the agents in patients. And on the y-axis, you can see the proportion of SB4O. So you can see that inanimate, animal, human, as we grow to go increase in the animacy hierarchy, across all three languages, you see a higher proportion of SB4O. And this is also note that this effect is nonlinear. So there's not a very big jump between, so there's a very big jump, sorry, between the inanimate entities and the animate entities, but there's little difference between the two types of animate agents. That means that human and animal agents were equally more likely to be expressed before patients compared to an inanimate agent. Okay. The next finding was that animate patients elicited less SB4O orders than inanimate patients. So as the patient increased in animacy, ranging from a complete inanimate patient or object to a human, you can see less SB4O orders. This means that animate patients actually induce the opposite pattern of O before S. Okay. Right. However, the effect of animacy is complex, and it actually depends on the relative animacy of the agent and the patient. Right. So the effect of agent animacy was modulated by the animacy of the patient, with the preference for this kind of fronting of subjects before objects, depending more on the patient's animacy than as the agent's animacy increased. So let me give you an example of what you see here across languages. So in the most prototypical scenarios, now Rabia, go back first.
Sorry.
Yeah. In the most prototypical scenario of an animate agent acting on an inanimate patient, and this is the case of woman dropping Tupperware, kind of like the prototypical case, the favorite word order would likely be SB4O, where woman is expressed before Tupperware. But in the non-prototypical event of an inanimate agent acting on an animate patient, for example, the ball or the watermelon that hits the man, here the likelihood of observing this SB4O or ball before man is actually lower. And the favorite word order here would be O before S. So where ball is expressed after man, not before. Okay. And the next thing to consider is the effect of language. The first thing that we found was we were able to replicate previous findings obtained from emerging sign languages for the presence of O before S word order tendencies. Okay, what we see here, and you can pass on. Yes. No. Yes.
This one. Sorry.
Yes. Great. Okay. So the patient before agent orders, or O before S, were more likely to appear in the emerging language of CTSL compared to both silent gesture, but not significantly different from TID. So you can see this kind of dip between gesture and CTSL. This implies that CTSL uses less prototypical SB4O orders, and by extension more O before S. Okay, now the next slide. So we also found this really interesting pattern of an interaction between language, age, and animacy. Specifically, what we saw is that signers of the established Turkish Sign Language, TID, were significantly more sensitive to the animacy of both the agent and the patient compared to CTSL signers. So TID signers, you can give the next bullet point.
Technical problem, sorry.
Okay, you can just leave it on this one. No, just leave the whole slide. Fine. So TID signers' preference for the agent before patient was more strongly affected by whether both the agents and the patients were human, animal, or inanimate compared to the CTSL signers. Okay, the next kind of interesting interaction we found is that compared to the silent gesture participants, the CTSL signers were less sensitive to the animacy of the agent, but more sensitive to this kind of interplay between animacy of agents and patients, so the relative animacy. And this means that it's actually not the case that the sensitivity to relative animacy is kind of monotonically increasing or decreasing with language age. So this developmental trajectory is not linear. Instead, our findings hint that there's a slightly more complex nonlinear pattern in which both silent gesture, the improvised system, and TID, which is the fully established system, both show stronger sensitivity to relative salience compared to the emerging language, CTSL.
Okay, thank you, Limor. All right, so all in all, animacy of the agent and also the patient are both important factors in shaping word order patterns. This is what we found in this study. As preceding all word orders are preferred for animate agents, and all preceding S orders are preferred for animate patients. These findings are consistent with previous findings of Kokab and colleagues, and also the salience-based account proposed by Mayer et al. So the greater the animacy asymmetry between the agent and the patient in an utterance, the more likely it gets to begin with the more salient entity, the one that is higher in the animacy hierarchy. The present findings are not consistent with Jacondov's agent first account, and this account seems to fail to predict any systematic changes in the distribution of all initial word order patterns. All right, so we would like to thank my students and research assistants, and also the Scientific and Technological Research Council of Turkey for generously funding this project. And thanks everybody for listening.
Thank you.